Welcome to the world of physics. So we were discussing about our last chapter, electricity and magnetism. So the last class we were just revising what we have learned in class 6. So there we have seen that what are the laws of magnetism, what is magnetism, what are the magnetic materials, non-magnetic materials, and I think I have said about natural and artificial magnets. There was a homework for you, laws of magnetism, and then you have written that 4 points and you have learned. So today we are going to discuss about electromagnetism. Electromagnetism. Before discussing electromagnetism, I think yesterday I have said that there are 2 types of magnets, artificial magnets and natural magnets, where natural magnets are formed naturally in the forms of rock pieces or the form of stones. And I have said that the artificial magnets are made by human being. So according to our use, we are able to define the shape and size of the magnet. So we are having bar magnet in the laboratories, round shaped magnets behind the speakers, and U-shaped magnets or horseshoe magnets in electric bulb. In artificial magnets, again we can divide them into 2: permanent magnet and temporary magnets. Permanent magnet and temporary magnet. Permanent magnet means when we are discussing about a magnetism, suppose we have made a magnet, artificially we have made a magnet. If that material is able to regain these magnetic properties for a long time, then we can consider them as a permanent magnet. A permanent magnet will have definite poles. We are not able to reverse their poles. Or once it is made to a magnet, the strength of the magnet cannot be increased or decreased. So it's permanent magnet. The magnet, after making the magnet, the material is going to retain or regain the magnetic properties or store the magnetic properties for a long time is called a permanent magnet. Now we are coming to the artificial magnet. What is artificial magnet? The magnets which is made by human being. In the artificial magnet, we have seen what is permanent magnet. Next one is temporary magnet. Temporary magnets means we are able to make a magnets through some processes. Maybe in class 6 we have learned about single touch method, double touch method, magnetic induction, electromagnet. In there we have just discussed what is electromagnet. So here we are going to make a magnet. That means when it is a certain condition, so when something is provided, then it will be acting as a magnet. For example, magnetic induction. If you are taking a pin, if the pin is attached to the magnet, the pin is also going to act as a magnet. That means another pin can be attached to that pin. That's called magnetic induction. Or we can say that when the electricity is going, when we are providing electricity, then only the material is going to act as a magnet. That means when the electricity is stopped, the magnetism vanishes. In magnetic induction, when the first pin is removed from the magnet, then the other pin also will be falling down from that first pin. So magnetism vanishes. So when magnetic field or certain things are provided, the object is behaving as a magnet, and when we have removed that providing, then suddenly the magnetism vanishes, or the law of magnetism or properties are there, it vanishes, then it is clear they are called temporary magnets. They are called temporary magnets. So today, first point we are going to discuss is electromagnetism. Electromagnetism. Electromagnetism, as it names, it is related to electricity. It is related to electricity. It said temporary magnet. Electromagnet is a temporary magnet. So here on the board I have shown a small diagram. Okay. Electromagnetism means, I think on page number 89 it is given, when an electric current is passed through a coil of insulated wire wound around a soft iron core, the soft iron core is going to act as a magnet. This property is called as electromagnetism, and the magnets such formed are called electromagnets. Very important, you can mark on your page number 89. When an electric current is passed through a coil, insulated wire wound around a soft iron core, the core behaves like a magnet. The property of this phenomenon is called electromagnetism, and the magnets formed is called electromagnet. So here, I am going to consider an iron core, soft iron core. I am going to consider a soft iron core. So I am having a soft iron core, just like this, a soft iron core I have taken, and I have taken an insulated wire wound, and I am going to wound this wire wound. Maybe some 10-15 times I am going to wound the wire wound around the soft iron core. There will be two ends for the wire. One end is given to the positive terminal of the battery, and the other end is given to the negative terminal of the battery, and this will be the direction of the current. So I have taken a soft iron core, and in the soft iron core I have wounded and insulated wire, and the two ends of the wire, one end is given to the positive terminal of the battery, and the second one is given to the negative terminal of the battery. Okay, now I am going to supply current through the wire wound. According to the electromagnetism, when the wire is carrying the current, this iron core is going to act as a magnet. That means magnet, there will be north and south pole will be there. So north and south pole will be there. Clear? So this is called electromagnetism, and such formed magnets are called electromagnets. Again, this phenomenon is known as electromagnetism. As I said, these electromagnetic magnets are temporary magnets. Electromagnets are temporary magnets because for the production of magnetism we have provided here current. So when we are making the switch off, or when we are stopping the current which is passing through the wire, suddenly the magnetism will be vanished. The poles are going to be vanished, attractive property is going to be vanished, directive property is going to be vanished, and upwarding magnetism is going to be vanished. It will be acting just like a normal iron core. So it is called temporary magnets. Electromagnets are temporary magnets. Once we have removed the current from the wire, suddenly the magnetism vanishes. But permanent magnets means there will be a magnet which is having north and south pole. These poles are actually fixed. That means we are not able to change the north pole to south pole and south pole to north pole. We can rotate the magnet. Is it not? Only that is the way how we can change the polarity. But in the electromagnet, we are able to change the polarity of the magnet. That means this north can be come to here, north side. This can be south direction. What we have to do? We have to just reverse the current. Now the current is flowing like this, from positive to the negative. So we are going to give positive, negative here, so that current direction will be reversed. This will be like this. So that suddenly what will happen? The poles also will be reversed. So electromagnets are temporary magnets. The second point that you have to remember is we are able to reverse the poles of an electromagnet. Third point, we are able to increase or decrease the strength of the magnet. We are able to increase or decrease the strength of the magnet. That means if it is a permanent magnet, there will be a certain region where the strength of the magnet can be felt. But regarding electromagnet, you are able to increase or decrease the power or the strength of the magnetism. So how you are going to increase? There are two ways. One is that you can increase the current That means here we have used one battery, we can give two battery or more than two. So if you increase the number of batteries, the amount of current which is passing through that wire will be more. So the amount of current which is passing through the wire is more, means the power of the electric strength of the magnetism will be higher. One more method is there. If you have only one battery, if you have a long length wire, suppose you have here 20 times, you make this number of turns to 50 times. If you increase the number of turns, then also what will happen? The number of turns, by increasing the number of turns, the strength or the power of the magnetism can be increased. This is another speciality of electromagnet. What are the specialities? We are able to reverse the means we are able to increase the interchanges or the poles. We can interchange the poles. The second one is we are able to increase or decrease the strength of the magnetism by controlling the current or by controlling the number of turns. Now, I think this is about our electromagnetism. So, this electromagnetism, that means they will be acting as a magnet only when the current flows. As soon as the current blocks or the current breaks, suddenly it will be acting just like an iron core by destroying or by destroying all the magnetic properties. Now, next one is that the applications of electromagnet. What are the applications of electromagnet? That means in electric motor or electric bell or electric switches, we are able to get the electromagnetism. That means electric bell is coming. The next portion we will discuss. The second one, for lifting heavy loads of iron, verbles and scrap. That means, suppose so many waste materials are dumped somewhere in the cities. So in the waste material there are magnetic material and non-magnetic material. So we have to separate them from the magnetic material from the non-magnetic material. So what we will do, just take a crane, that there will be a hand will be there. On the hand there will be they will place an iron core, rectangle shape iron core they will shape, and on that one wire loop will be there, and this waste materials are there. The hand is brought near to the waste material. Suddenly the driver will be switching on the switch so that current will be passing. When the current is passing, it is going to act as very strong electromagnet. It will be stuck, and this will be taken to one side. The driver is going to switch off. Then suddenly the magnetism vanishes, attractive property vanishes. This magnetic material falls down. So the magnetic materials can be separated from the non-magnetic material by using of electromagnet. The next one, in mining industries, we separate iron ores. That means we know that iron is actually mined from the part of the earth, and when we are mining this one, there can be stone pieces can be there, rock pieces can be there, limestone can be there, other ores can be there. So we have to separate iron ore. Iron ore means it will be attracted towards the magnet. So this electromagnet is strong. Iron ores are going to be attracted to the electromagnet. When we are switching off, the magnetism vanishes. We can separate the iron ore from other things. The last one is to deflect beams of electrons in television. To deflect beams of electrons in television. That means earlier, nowadays we are using LED TV and LCD TVs. Earlier we were having TVs, you know that its size is bigger. Backside there is a compact like this, you can see. That is called a picture tube. So from the picture tube, these electrons were emitting. That is actually by using of electromagnetism. As a result, we were able to get the pictures on the screen. Nowadays we are not using, but for that also we were using electromagnets. So this is about electromagnets and their application. I hope you understood. The second portion of today is electric bell. So now we have learned what is electromagnet. On basis of electromagnet, we are going to learn how the electric bells are working and how what are the main parts. And this electric bell is very familiar for you, and you know that after every period we are getting bell here. And you can see electric bell if you go near to the bell, and we are going to study how it works. So this is the diagram of a, this is the diagram of an electric bulb. This is the diagram of an electric bulb. Electric bulb works on the principle of electromagnetism. Okay. Here we have used a circular cylindrical shaped iron core, but here we are going to use a U-shaped iron core. You can see a U-shaped iron core I have placed here. Okay, so how the electromagnetism was working when the current is passed through the wounded wire, it will be acting as electromagnet. So I have given a cell here. From the cell, the current is passing. That means this is the positive terminal. The current is passing, and this is attached to the armature. Armature, from the armature it is given to the wire loop, is given to the soft iron core wounded, and it is given to the negative terminal. So when the switch is on, what will happen? The current will be passing. When the switch is on, the current will be passing. Now, when the current is passed through this U-shaped iron core, what will happen? Due to electromagnetism, this U-shaped iron core will be acting as an electromagnet. U-shaped iron core will be acting as an electromagnet. Now, when this iron core is acting as an electromagnet, what will happen? This is actually made of, this armature is made up of iron. Armature is made up of iron. So what will happen? This will be attracted by the electromagnet. Iron is a magnetic material. It will be attracted by the electromagnet. When it is attracted, what will happen? It will come down and touch on this one. Touch on electromagnet. So when it is coming down, see this connection is coming this way. So when it is moving down, what will happen? This connection is going to be break. So this will be broken. That means the wire, the circuit is going to be broken. So what will happen? Circuit is broken means just like when we are switching off the switch. Suddenly, when the circuit is broken, when it is attracted down, this hammer will come and strike on the gong, and the gong will produce the bell sound. So when the current is passed through the U-shaped iron core, it will be acting as an electromagnet. Electromagnet is going to attract the armature down towards since it is a magnetic material. So when it is moving down, this hammer will come down and strike on the gong. Clear now? So sound is produced. But when the armature is coming down, the circuit is going to be break. As a result, there will not be any current passing through the circuit. So when this current, there is no current, what will happen? The towards electromagnet, suddenly the magnetism vanishes, it will become a U-shaped iron core. So this attraction vanishes, the property of magnet, so the armature will move up. When it is moving up, again it will go and touch on the spool. Again the current will be passing through the circuit, and what will happen? It will act as an electromagnet. Armature will come down. The hammer is going to strike on the gong. Again, circuit breaks. Electromagnetism vanishes. Armature goes up. So, up to when the switch is on, this process will be continuously happening. That's why we are able to hear a continuous bell when we are after a very period and interval time. Got it now? This is how the electric bell works. Nowadays in home we are not using this type of bell because already we know that science is developed and we are using maybe digital bells we are using. There you can see so many different voices, the voice of maybe birds or etc. can be there. But in school we are using the bell which is working on this property. So if you go to the near to the bell, you can see a gong is there and a hammer you can see. The rest of the thing will be inside that cover. Okay, so this is how electric bell works. So once again, when the switch is on, the U-shaped iron core is going to become an electromagnet. Electromagnet will attract armature made up of iron material or a magnetic material. As a result, there will be a break between the screw and the armature. So circuit is broken, magnetism vanishes, it will move. Again, when it is touching, again the magnetism installs and armature comes down. As the armature comes down, the hammer is going to strike on the gong and sound is produced. So this is how electric bell is working. So working of electric bell and diagram is given on page number 890. So you have to study it very well. Very important question. Now on page number 90. One contact adjustment screw is shown on the figure. It's given. What is the function of contact adjustment screw? The first function is to control the frequency. It can increase or decrease the frequency. Suppose we know that the frequency of our school bell should be very high. You know, it is very sharp sound. So by adjusting this screw loosen or tight, we are able to change. We are able to alter, increase or decrease the frequency of the bell. And we know that when we are using the bell in a home, the bell is that means frequency is very less, but in school it is very high. Are you able to stand there just below the bell for a long time? It will be very hard feeling. Already we have studied about the frequency. So the frequency of the bell is controlled by this contact adjustment screw. Again, also helps to prevent sparking. That means when it is going, coming and touching, going away, again coming and touching, there can be sparking can be there. So the screw will control the sparking also. The screw is going to control the sparking also. So this is how electric bell works. I hope you understood how electric bell works. So on page number 90, some check your progress is given. That is your homework. The homework is to complete your check your progress in a rough copy, and true or false is there, so you read it very well, and if it is something false is there, you have to rewrite it to the correct statement and answer the following question. What do you understand by the directive property? Yesterday's homework you have written. What is meant by electromagnetism? I told you to mark that one. There is there. What is the function of contact and screw in electric bell? Page number 90 in the box it is given. So go through the class, go through your textbook, read well, complete the homework. If there is any doubt, you can contact me.